Now we are going to learn what is a transpose of a matrix. So this transpose is very important when you think about finding the inverse and all. So all concepts are coming together in the inverse. So if you have some matrix, say 1, 2, 3, 4, 5, 6, how do you find the transpose of that? First of all, how do we represent what is a transpose? If A is a matrix, A dash or AT represents the transpose of that matrix. So what is the transpose of that matrix is, in this transpose you are just going to interchange the rows and the columns. So let us see how it is going to be here. If this is of the order 3 by 2, its order of this is going to be 2 by 3. Therefore it is going to have 2 columns and 2 rows and 3 columns. So I need to fill it in this order itself. Since 1, 2 is there, 1, 2, then 3, 4 is like this. So this column is to be together and 2, 4, 6 should be together. Therefore this becomes the transpose of that. Okay, so you can just simply understand what is the transpose. So if you take the transpose again of this, so maybe I can consider transpose of transpose. At last you are going to get A. That is what you are going to get. This is the properties of transpose of the matrix. So I hope you understood what is the transpose of matrix, just interchanging the rows and the columns. So if I take the transpose of the transpose, you are going to get back the matrix. And the second one is transpose of K into A dash, that is transpose of K is same as K into A transpose. You read as A transpose. So there is just direct. You can, if you want, you can remove that things and all. In the next thing is A plus B whole A plus B whole transpose. I can write it to be A transpose plus B transpose. Then you have the fourth option, that is AB whole transpose is equal to B transpose into A transpose. All these questions mainly when comes, you are asked to prove this statement. Okay, you are given a matrix, say an identity matrix. So if you are given like that, you are asked to find this A transpose and find the transpose of that at last, and then prove that this given statement is going to be true. So only such things is going to be applicable, but this is very important. Here it is going to be inverse. I'm not the inverse, it's going to be the opposite, because here it is AB, here it becomes B dash into A dash. Okay, based on this we can learn about different types of matrices. Okay, so there exists some different types of matrices other than the square matrices and all those things we learned about. So now we are going to learn about symmetric matrix. What is a symmetric matrix? By definition, symmetric matrix is such if A is equal to A transpose. If A is equal to A transpose, A is a symmetric matrix. So if I consider an identity 1, 1, 0, 0, its transpose is also going to be 1, 1, 0, 0. Therefore, A, if you consider the identity matrix, it is going to be, you understood that if A is a square symmetric matrix, then it is going to be A is equal to A transpose. If it is a skew symmetric matrix, then A is equal to minus A transpose. That is what you are going to get. So if you consider matrix, say 0, 0, 1, minus 1, then its transpose, this transpose is going to be 0, 1, minus 1, 0. That is minus times A. That is A transpose is equal to minus A. Therefore A is equal to minus A transpose is what you infer from this. So the one very important here is skew symmetric matrix, always the diagonal elements are 0. That is always true. All the diagonal elements should be 0, whatever will be the size of the matrix. Okay. The next we have to learn 2 theorems. After that I'll just wind up and do the exercise in the next class. Okay. Now we have your theorem. The theorem states that every matrix can be, for every matrix A, A plus A transpose is symmetric and A minus A transpose is skew symmetric. I will just prove that. If you consider B is equal to A plus A transpose, then what is B transpose? That is equal to A plus A transpose whole transpose. So therefore how much we are going to get is A plus B whole transpose is A transpose plus B transpose. So we're going to A plus A transpose the whole transpose, that is A transpose plus A. Okay, that is equal to B. Therefore B transpose is equal to B. Therefore it is symmetric. It is going to be symmetric. So if you consider one more C, for which C is equal to A minus A transpose, then you can find out that C transpose is equal to A minus A transpose whole transpose, that becomes A transpose minus A transpose whole transpose, that is A transpose minus A. So you can write it in the form of minus of A minus A transpose or minus C. Therefore C transpose becomes minus C. Therefore it is going to be skew symmetric in this case. Okay, this is the first theorem. We'll learn the next theorem now. Okay, you have your second theorem. Second theorem says that every matrix A can be written as a sum of symmetric and skew symmetric matrix. So I need to write A as something. So I know that A plus A transpose is symmetric. A plus A transpose is symmetric and A minus A transpose is skew symmetric. Okay, this much I know. So I can write half of this one plus half of this one is going to be A. Even if you just multiply and add and see, you get half A plus half A, then half A transpose plus minus half A transpose. So that A transpose thing is going to get cancelled. So directly you can tell. So therefore in this form you can write it as the sum of the symmetric and skew symmetric matrix. Okay, this is a very important thing. Many a times the question just comes, you write it as a sum of symmetric and skew symmetric. You will not know what to write. So you need to know that this half of A plus A transpose is going to be the symmetric part and half into A minus A transpose is going to be the skew symmetric part. Okay, thank you for now. In the next class we'll learn about the exercise 3.4 and then we'll move on to elementary row operations, exercise on that, finding the inverse, and also at last we'll move on to the miscellaneous exercise. Till now we have learnt about what is a transpose of a matrix and skew symmetric as well as symmetric matrix based on the definition of transpose. Let us revise it once more. If it is symmetric, then A is equal to A transpose. That means that A is a symmetric matrix. If A is a skew symmetric matrix, then A is equal to minus A transpose. And one more thing to take care is, if it is a skew symmetric matrix, all the diagonal elements always be 0 and no other number. Okay, now we'll start with exercise 3.3. The exercise 3.3 is very simple, as this is also whole chapter is simple. So the first question is finding the transpose of something. So while you find the transpose of something, you are going to interchange the columns and the rows. So let me do only the first one out of that. Other two you can do yourself. So the first one is 5 half and minus 1. 5 half and minus 1. So what is the transpose of this? Transpose is a symbol like this, or I can write it as T over there. So I'll find the transpose of this. Since this is of the order with 3 rows and 1 column, so it is going to have 1 row and 3 columns. So this is what you are going to get at last. So for that you need to change the rows. Here only 1 column is present, so that column is going to be the row. That is a direct one. 5 half and minus 1. Okay. Similarly you are going to do the second one also. Okay, maybe I'll do the second one because it is a square matrix here. So you need to find the transpose there. It is given 1 minus 1, 1 minus 1, 2, 3. You are asked to find the transpose of this matrix. It is going to be a 2 by 2 matrix only because it is a square matrix. The matrix, this one also will have the same. So one more thing you need to take care about the transpose is, always it is going to be having the diagonal elements the same. So diagonal elements always remain the same, and here it is going to get interchanged. Get minus 1 here and 2 here. That is just transpose. Okay. That much is over. Now we have the third subdivision. That's simple. Based on this you can do. Okay, now you have your second question. Second question is based on just verifying. I think you know addition of matrices and finding the transpose of the matrices. Just you need to verify that based on LHS is equal to RHS. So it is given, two conditions are given and two matrices are given like that. So even in the third question is the same. It is about verifying. So verifying two things just based on what is given over there. Fourth one is about finding A and A plus. Finding A plus 2B whole transpose. Okay, let me do that question. Fourth question. Okay, you have a fourth question here. The fourth question you are given A transpose and B. You are asked to find A plus 2B whole transpose. So first of all, let me find A from A transpose. Maybe that is not required. I'll find B transpose first. Okay, let it be B transpose. What is B transpose is? The diagonal elements are going to remain the same. So it is going minus 1, 2 like this only. And these are going to get interchanged. So it is becoming 0 and 1. 0 and 1. This is the B transpose. So this is what you are asked to find out in this question. So by using the properties of transpose, you can just split this. So A plus B whole transpose, in that A plus B whole transpose is equal to A transpose plus B transpose. So I can write this of the form A transpose plus 2B whole transpose. Okay. You also have one more property, K into B the whole transpose is same as K into B transpose. Therefore I can write it to be A transpose plus 2 times B transpose. Okay, let me write A transpose, that is directly given in the question. Okay, plus 2 times the B transpose, that is minus 1 1 0 2. Okay, I'm going to add that now. You are getting minus 2 plus 2 into minus 1, that is minus 2. Again it becomes minus 4. 3 plus 2. 3 plus 2 is 5. Then 1 plus 0. 0. 2 plus 2 into 2. That is 4 plus 2 is 6. This is the answer that you're going to get. The thing is here, how you are getting these properties. This property and this property. That is the thing you need to be more specific on, rather than just finding A, B and transpose in the last. Okay. This is the easier way. Rather than you can find A transpose of A, you will get you're going to get A here after finding its transpose, and later you can substitute here and find the transpose at last. Both have the same. Okay. Next you have the fifth question. The fifth question is again based on the result, that is AB whole transpose is equal to B transpose into A transpose. That thing you are going to use, that is going to be verified by the left hand side and the right hand side. You can do it by yourself because it is just about matrix multiplication, finding the transpose and again multiplying. You are going to get the same whatever it is. Okay. In the sixth question, you are going to do now. Okay, now we have the sixth question. In the sixth question, first and second parts are similar. That's why I'm going to do the first one. The first one that is given, A is equal to this matrix, that is cos alpha, sin alpha minus sin alpha, cos alpha. So you are asked to prove A transpose is equal to I2 because it is of 2 by 2 matrix. So identity matrix also should be of order 2. So first of all I'll find A transpose. A transpose, however, the diagonal elements are remaining the same and these two are going to get interchanged. If you interchange this becomes sin alpha and this becomes minus sin alpha. Now the next thing is you need to find A transpose, that is cos alpha minus sin alpha cos alpha into cos alpha sin alpha minus sin alpha cos alpha. Okay, the remaining thing is just about multiplication, matrix multiplication. Cos alpha into cos alpha, cos square alpha plus sin alpha into sin alpha, first row first column. So it is going to be cos square alpha plus sin square alpha. Okay, then you have this part. Then in this point it is going to be cos alpha into minus sin alpha, that is going to be minus sin alpha cos alpha plus sin alpha into cos alpha because you are considering the second column. So it is going to be, however, 0. Okay. However, you know that it is going to be identity matrix. You can write this also 0. Okay. At last, you need to get. Okay, we'll see once more. You're going to get sine minus sine alpha into minus sine alpha is sine square alpha, and you have cos alpha, cos alpha. So adding, it becomes like this. So just by our trigonometric identities, we know that cos square alpha plus sine square alpha is equal to 1. Therefore, it is going to be the identity matrix of order 2. Okay. Then you have the second subdivision. They have just interchanged that cos and sine. That they have made up another question over there. Nothing else in that. Okay. Next, we'll move on to the 7th question. The 7th question is all about the condition where it is symmetric and where it is skew symmetric. Okay, now we have a 7th question. In the 7th question, the first part is to prove that A is symmetric matrix. If it is a symmetric matrix, then you know that A should be equal to A transpose. So, however, you need to find A transpose in this case also, because you are asked to prove what is that A is going to be a skew symmetric matrix. So, first of all, we'll find A transpose in both the cases. A transpose. Finding out A transpose is very easy. Take the diagonal elements, they are going to be the same. Interchange these two, the corner elements, interchange these elements also. That is minus 1. No, you need to interchange based on this line. If you are considering this as the line, if it is going to be mirror image along this line, then you can consider it to be a symmetric matrix. That is just by seeing. But while finding, you need to find all these things. So it is going to be like this only. So you can tell that A is equal to A transpose, therefore symmetric matrix. Okay. Then you have A transpose here. However, all the elements are going to be 0 because it has to be a skew symmetric matrix. You are asked to show that. So now when you interchange based on this line, you need to interchange minus 1 with 1. So this becomes 1 and this is minus 1. The corner elements also I need to change. So 1 and minus 1. So this becomes minus 1, 1. And this and this. So it is going to be 1 minus 1. 1 minus 1. Okay. That is, I can write it as the form minus of 0, 0, 0. Minus 1, 1 minus 1. 1 minus 1, 1. This is same as A minus A. So therefore I can tell that A is equal to minus A transpose, therefore skew symmetric matrix. It is going to be a skew symmetric matrix. That's what you can find out here. Okay. In the next question, that is 8th question, you are just asked to find out what is A plus 8, whether A plus A transpose is symmetric and A minus A transpose is going to be skew symmetric. You are just asked to verify that using one of the examples. So one example is given over there, 1, 5, 6, 7. Directly you can do that. Even though we had already done in the algebraic form how to find and all, but still we are going to do. But this is very simple when compared to that. Okay, now we have your 9th question. In the 9th question, you are given a matrix. You are given a matrix. Let me name it to be B. Always, some B. Okay, it is given A only. See, why should I take B over there? This is A. So it is given all the diagonal elements as 0. Therefore, maybe it's a chance of a skew symmetric matrix. Then it is going to be minus A, minus B, minus C, A, B, C. Okay. So for this, the question is given as half of A plus A transpose, half of A plus A transpose you are asked to find out, and also half of A minus A transpose. Okay. In the second theorem we understood that it can be two types. This can be written in the form of symmetric as well as skew symmetric, sum of those two. So if I consider this to be the sum of these two, this is going to be the symmetric part. This is going to be the symmetric part, and this is the skew symmetric part. Okay. You can do it directly, but still I am just showing a shorter method when compared to the what is directly method and all. So you can find out that this is symmetric and this is skew symmetric. So A here is going to be a skew symmetric matrix. So maybe I'll find out A transpose and just show you that it is going to be A, B, C minus A minus B minus C. Okay, this is same as minus A. Therefore, A is equal to minus A transpose. Therefore, it is a skew symmetric matrix. Skew symmetric matrix. Therefore, A minus A transpose is going to be something. But A plus A transpose, if I bring it to the left hand side, that is A plus A transpose is equal to 0. Therefore, this matrix is going to be a 0 matrix. That is a 0 matrix. And you know that you can write one matrix as the form of half of A plus A transpose plus half of A minus A transpose. Or maybe I'll use the same thing over there also. What is A minus A transpose is same as A minus of, what is A transpose is minus A. Okay, half you have outside, half. So you have A minus of minus A, that is 2A, and half. So this 2 is going to get cancelled, you are going to get A. Therefore, whatever A is present, that is going to be the sum here. Okay, only this much is the answer. All the remaining things was the explanation. So you are going to get the first part, that is half of A plus A transpose as a 0 matrix, and you are going to get half of A minus A transpose as a same matrix given, that is A. That's how we found out without using that method what was given there directly. Even directly you can use, but this is more logical when compared to that. That was full methodical. You need to just find a transpose over there and find out A plus A transpose and make half of that. So this was a better one, I think. Okay, the next question is about expressing one matrix in this form. Okay, let me not wrap that part. Okay, it is given that every matrix can be written as a sum of symmetric as well as a skew symmetric matrix. So we know that this is a symmetric and this is a skew symmetric matrix. Skew symmetric matrix. So first, for that we need to find these two matrices based on the given things. So out of the 10th question, I'll do the two bigger ones, that is the second as well as the third subdivision. Okay, let me write these subdivisions for a while. Okay, you have your 10th, I've written both of them. So let me mark one of them as A. So maybe I need not write that A, I'll find the transpose now. What is the transpose of this? So maybe I'll write it as some T. T stands for transpose. It doesn't stand, but for me it is for transpose. This for me to understand what it is. So it is going to be the corner elements are going to be the same. Then you have to interchange these two. This 2 and 2 is again interchanged. That becomes 2 itself. Then you have minus 2, minus 2. Minus 2, minus 2. So since A is equal to A transpose, that means that this is going to be a symmetric matrix. So as if you have to write it in the sum of a symmetric as well as skew symmetric, but you have this as directly a symmetric matrix. Therefore the remaining thing is going to be 0. Therefore I can write this is going to be equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, plus the 0 matrix, that is 0, 0, 0, 0, 0, 0, and 0, 0, 0. This is the skew symmetric and this is the symmetric. Okay, this much I found out. Now we'll go to this one. So now we are to find the transpose of that. So what is the transpose is to be? Maybe the diagonal elements are going to be the same, right? Always. Now we'll interchange minus 2 and 3. So minus 2 comes here and 3 comes here. Then you have minus 4 and minus 1. It comes to be minus 1 here and minus 4 there. Minus 5 and 1. So 1 and minus 5. This is going to be the transpose. So however, we have this form. So I'll wrap this first part here. I'll wrap that first part because it was a very simple one. So we'll go how to find out the symmetric and the skew symmetric part. So if it is a symmetric part, I need to find A plus A transpose and half of that. So I'll mark it as the equation. So directly I'll write, I did not write this again and again, 1 plus 2 and all. So 3 plus 3 is going to be 6 here. Then you have, maybe the diagonal elements I can just double it and write. So it is going to be like this. Okay, because both of them have the same at the same position. So now you have here minus 2 plus 3. Minus 2 plus 3 is 1. Then minus 4 minus 1 is minus 5. Then you have minus 5 minus 5 plus 1 is minus 4. Then you have 3 minus 2. 3 minus 2 is 1. So it is going to be symmetric matrix. So if you find this much, remaining things you can just write it as it is, if you are confident that you are correct. Okay, it has to be correct if it is right. So if I'll write it, I'll take this half inside. Maybe I can write it as 3 minus 2 2, 1 by 2 minus 5 by 2 minus 2, and you have minus 2 here, 1 by 2 and minus 5 by 2. This much is the symmetric part. So now we'll find the skew symmetric part, A minus A transpose. So I'll write it as half of, so however it is a skew symmetric, so the diagonal elements are going to be 0. And first of all, if you find this, I'll make the negative of that sign and put over to the other side. So first we are going to do A minus A transpose. So minus 2 minus 3 is minus 5. Then you have minus 4 minus of minus 1, that is minus 4 plus 1, that becomes minus 3. Then you have minus 5 minus 1, that is minus 6. Therefore it is going to be 5, 3 and 6 here. So we'll check once more. 3 minus of minus 2 is 5, correct. Minus 1 plus 4 is going to be 3. Okay, 1 minus of minus 5 is going to be 6. That's all right. So we'll just go on making it in the similar form. So it's going to be 0, 0, 0 and 5 by 2, 3 by 2, 3, 3, 3 by 2, 5 by 2. This is all minus. Okay, this is the two things you are going to write. Therefore you can write it as this is equal to this matrix plus this matrix. Okay, that is a symmetric and this is skew symmetric. So therefore this matrix you are writing it in the form of symmetric as well as a skew symmetric matrix. The remaining questions is about the 11th and 12th. 11th and 12th are the MCQ questions. So the 11th question is about A and B are symmetric matrices of the same order. A and B are symmetric. Then you are asked to find AB minus BA. AB minus BA, whether it is skew symmetric, symmetric, zero matrix or an identity matrix. So what is given in the question is A and B are symmetric. If A and B are symmetric, that means that A is equal to A transpose and B is equal to B transpose. Okay, what is given in the question here is AB minus BA. AB minus BA. Maybe I'll find the transpose of that to make it better to understand. So maybe I'll find a transpose of this to check whether it is going to be symmetric or a skew symmetric. If it is not going to be anything, so we'll check later. If it is identity or zero matrix, we'll think about that later. Okay, now you have the transpose, so it is going to be AB whole transpose minus BA whole transpose. Okay, then again using the properties, AB whole transpose becomes B transpose A transpose minus A transpose B transpose. Okay, this is what you are going to get. So you'll find what is here. Okay, so you know that A is equal to A transpose and B is equal to B transpose. So you are going to substitute that. This becomes BA minus AB. That's same as minus of AB minus B. Okay, if I consider this to be C, then this becomes minus C transpose. If I consider what is there inside a C, then C transpose is equal to minus C. That stands for C is skew symmetric. C is skew symmetric. Maybe I'll bring this their side. That is same as C is equal to minus C transpose. Therefore, it is going to be skew symmetric. That stands for the option A. Option A is given. It is a skew symmetric. Okay. Now we have your 12th question, last question of the exercise. It is given A is equal to cos alpha minus sin alpha cos alpha. You are asked to prove A plus A transpose is going to be I, and you are asked to find the value of alpha. I think it's simple, but still I'll go on doing that fast. So it is given a cos alpha sine alpha minus sine alpha and cos alpha again. This is A, and you need to find A transpose. For that, just interchange the things that is in the corner except the diagonal. So it is going to be minus sine alpha here, and it is going to be sine alpha here. If I add both of them, that is A plus A transpose, then it is going to be cos alpha plus cos alpha is 2 cos alpha. Then you have sine alpha minus sine alpha plus sine alpha 0. Here also 0, like that. So cos theta plus cos theta, cos alpha is 2 cos alpha in both the case. It is given that it is going to be the identity matrix. Because it is of order 2, I can write it as 2, or I can write it of the form 1 0 1, no 0 1. Okay, therefore I can tell that both the conditions say that 2 cos alpha is equal to 1 or cos alpha is equal to half. Cos alpha can be half when alpha is equal to 60 degree, or I can write it to be pi by 3. This option is in the B. That is what you had asked to ask. Okay, next is the 3.7, what is given in the textbook. Okay, whatever name, elementary transformations. Okay, we are going to learn about elementary transformation, what is the inverse of the matrix, and so on.